Okay, so what I want to say is now we only have to we still have to set up some extra elements here like linear regression and the set engine here. So this is for linear regression. Okay, but what if we change to different models here? Okay, so if you check the uh, if we want to use the GLNet, okay, GLNet, so this is the different model, which is a generalized linear model. And if you want to use this function, then you have to set up the parameters according to the function setup. Okay, so if you want to, this is the on the left hand side, this is the traditional model you need to follow. But if you use tidy models, you don't have to do anything except you only have to change the set engine here. Okay, change from LM to GeoNet. Okay, so everything will be the same. So this is the greatest advantage of the tidy models package. So I just like you to become more and more familiar with the tidy models. Okay, because in the future maybe you need to use many different types of models. Okay, so you can just change just one line of codings, and then you can generate the same results here. So this is one example. And of course, other examples like, for example, most of the time we will use the H2O package. Okay, so H2O package is also a very popular machine learning package in R. But if you want to use a H2O package, for example, like here in this case on the left hand side, you have to use H2O dot GRN. Okay, and then you have to set up the parameters like X and the Y. Okay, X, we have so many explanatory variables, and Y is dependent variables, and this is the empty colors. But on the right-hand side here, you only have to use tidy models. Okay, you only have to change to the set engine to H2O. Okay, so that's all you need to do. So this is one great advantage we need to know, okay, about tidy models. So in the future, I like you to become more and more comfortable and more familiar with the tidy models, especially if you are looking for examples in running machine learning in R. Hopefully you can become more comfortable using the tidy models here. And of course, there are the one great books. There's one great book about the tidy models. I will show you later. Okay, so there are several other reasons why we need to use tidy models. So the first one is the safety. Okay, so you can see here we have a data leakage. Okay, so this is one problem. Also, another problem is about overfitting. Okay, overfitting leads to analysts believing models are more performant than they actually are. Okay, so this is just for your reference. And then we also have another one. We call it as irreproducibility. Irreproducibility. Okay, so implementation of the same machine learning model give different results, resulting in irreproducibility of model results. So because of this, we are changing our package to tidy models. Okay. So this is important just for your reference. And of course, there are other great functions, for example, like tidy models. Tidy model as an object can be easily visualized. For example, you can use the autoplot to generate the uh, receiver operating curve. Okay, so you can see we call it the ROC curve here. Okay, and besides that, we also have some built-in support for one and two data pre-processing techniques. Okay, so there are so many pre-processing techniques if you want to process your data. Okay, so this is for your reference. And other issues like uh, maybe you like to deploy your machine learning models on the cloud so that your group or your teammate can use your machine learning models, okay, as well. So if that's the case, then you can just try to integrate with your platform on the cloud. But because the author is also a team of the POSIT, okay? So they are trying to integrate with Vetiver and the POSIT team. So in other words, in the future, you can install your machine learning on the cloud, and then you can run the machine learning models directly. So you can see the following here. There are several examples down here. Okay, so this is just for your reference. And finally, I just want to show you the book, reference book here. Okay, here's a reference book. We have two references here. This is the first one, R for data science. Okay, so this is the second one, Tidy Modern with R. Okay, the author is Max Kohn and Julius Silge. So basically, these books are totally free and available on the cloud, so you can check out the books by yourself. Okay, so this is just for your reference here. Okay, any questions about this? Machine learning is quite new to all of us right now, especially in finance major students. So I like you to open your mind, okay? Open your mind to read these materials and try to understand these materials as much as you can. But of course, some theorems or some derivations are quite difficult, especially for finance students. But don't worry, yeah, we are focusing on the application side. Basically, what I like you to know is that you need to know how to apply these models to the real data, okay? And of course, behind the codings, there are some black boxes, especially like some difficult theories or difficult mathematical derivations, whatever. But what I need you to know is that, okay, what's the purpose of this machine learning? Okay, so because there are so many different machine learning models there, we still have to know how to compare these machine learning models, okay, in terms of their accuracy in predictions and and so on and so forth. So there are many things we need to know. So okay, so I also made a little bit just a minor modification of this slides. Maybe you can ignore this modification, but basically we covered some issues already. Okay, so let me just finish this. Okay, so we covered some issues in classification. Basically, we covered the LDA and the QDA, and of course also includes the naive Bayes. Okay, so but of course these models contain different characteristics. So maybe you have to know the difference by implementing the codings from the example I've shown you in your homework. So you just try to compare. All you have to know is just try to compare the accuracy of prediction. Okay, but of course there are some minor issues like, for example, like the structure, the data structures. For example, when to apply the LDA or when to apply the QDA. So you still have to go through many practices in understanding your data structure. So this is another issue. But of course, we also highlight some key points in applying these models here. Okay. So for example, like we do have some assumptions by naive Bayes. For example, like if you want to use naive Bayes, basically naive Bayes, we have assumption that these covariates are independent within each class. Okay, so if these are independent, then we better have we can have a good reason to apply the naive Bayes to the data. Okay, but of course, just like the slide shows here, the naive Bayes assumption introduces some bias, but it reduces variance, okay, leading to classify that works quite well in practice as a result of bias variance trade-off. Okay, so you can see from your homework. Okay, so this is your homework web page about the classification. So the purpose of this example is to apply the tidy models to the stock market data. Okay, stock market data. So now we will see at the end of this output here. So you can see that we've seen logistic regression application here. Okay, so this is the uh, logistic regression. Then we also have okay, we also have a LDA, okay, which is linear discriminant analysis here. And then we also have a quadratic discriminant analysis here. Okay, we are using the same data with different applications of the models. Okay, and then finally we will have naive Bayes. Okay, so you can see we are using a naive Bayes, and finally we can calculate the accuracy here. Okay, we can also calculate accuracy here. And then based on this example, then you can find that, okay, maybe some models are performing quite well, but most of the models are not. Okay, so what's the reason? What's the reason? If you are really concerned about the reason, then probably you need to go back to the data structure. So you can see here, the first of all, we need to check out the relationship, okay, among the covariates. So for example, like we have some covariates here. For example, in this case, we are using lag1 and lag2 as the explanatory variables. So in this case, if the lag1 and lag2 doesn't show any relationship, okay, and if that's the case, then we have a good reason to apply the naive Bayes, because we are assuming that the explanatory variables or covariates are independent with each other. Okay, so that's a very important feature. Okay, and of course, we also have some assumptions by LDA and QDA. So you can see there are some special requirements for LDA and QDA. We mentioned that before, so we will cover that again. But this is what we have discussed here. So this example is great. It's great. And finally, we also the web page also include one or two more models. For example, like KNN models, K nearest neighbors. We will discuss that a little bit later. And then we also have a Poisson regression. Okay, so Poisson regression is also important. So finally, after including these two models, then we can compare these models together. Okay, so you can see here, finally, we will see RC curve here. Okay, we are comparing the performance of KNN, LDA, logistic regression, and QDA. Okay, so I think this plot is great because you can see very clearly from their RC curve. Okay, so from this plot, you can see here the QDA is performing as good as the logistic regression. Okay, logistic regression seems like this. Okay, and the purple line is QDA, and the green line is logistic regression. Okay, so of course you can see here the note by the author is that LDA, you can see LDA because it lies perfectly under the logistic regression. Okay, so this is for your reference. I think this is a great example. Maybe in the future you might have many different financial indicators or financial features coming from the market. Then maybe you can ask the market to help you, or machine learning models to help you to make your predictions. Okay, but I must say that from my viewpoint, for example, if you want to trade, if you really want to generate trading, better trading skills or better trading profits, I think trading by yourself, okay, trading by yourself is the first step to learn lessons from the market. Because I still want to emphasize that machine learning is just a box to collect many information, lots of information from the market. So you still have to filter the information, but basically machine learning is just something like that. We have to set up some rules for the machines, okay, and then the machine can learn the data by itself by following the rules to learn the trading skills during the training process. And then so based on this, then the machine can improve itself every time it trains itself based on the training data. Then we can improve the trading skills by the machine learning. But let's face the reality, we still have to train ourselves in the real market. So I still want to emphasize that trading from the market, especially like the trading test, okay, I have assigned to you, okay, in the beginning of this semester, I still like you to do some tradings. For example, there are lots of trading opportunities out there in the trading market. For example, you can use TradingView as a platform to train yourself. Okay, I think this is a good, it's a better way, okay, to improve your profits. But theoretically, we still have to learn what exactly these machine learnings are about. Okay. Okay, so in the following, we have a summary of the comparison of the classification methods. So we mentioned that before, but let's just repeat again. So LDA is a special case of QDA. Okay, we mentioned that. So any classifier with a linear decision boundary is a special case of naive Bayes. Okay, so neither QDA nor naive Bayes is a special case of the other. Okay, so we have a summary of 5 points. Okay, and okay, so the reference. Okay, so now we are going to discuss the Poisson regression. So I just included some videos about Poisson regression. Uh, I'm going to show you just one click here. Just give me a minute. Okay, so this is the professor in British Columbia, I think. It should be, but I'm not really sure, but I just saw his data. Okay, he's a professor in British Columbia, and there are several series. There's a series of Poisson distribution, and I think these videos are quite good. So maybe you can watch these videos, and maybe you can get a better understanding about the Poisson regression. Okay, so this is just for your reference. I don't know how to. I'll try later, but I just want to show you here. Okay. So, okay. So we have 1, 2, 3, 4, 5, 6, 7. Okay, we have 7 videos, but basically these videos are quite short. Okay, maybe some videos will take only 5 to 10 minutes only. Okay, so I suggest you to watch these videos by yourself. Okay, and but basically, uh, there are some this Poisson regression basically is to feed the model to count data. Okay, so but in finance, maybe we don't have so many opportunities or so many cases to handle this kind of data. Okay, so I don't want to spend too much time discussing this model right now because most of the time this model uh, is widely applied in medical cases. Okay, especially for doctors. So you can see from the videos, they are using the doctors' medical data, okay, to analyze the how many deaths, okay, how many deaths in emergency room each year, okay, for a specific hospital. They like to model the counts of the death number for patients. So, but in finance, I can't find a very great example to apply this model. Okay, so I just want to show you that, okay, we do have this uh, Poisson regression model for count the data, but that's all you need to know. Okay. Okay, so let's start from the Poisson regression. So before we start from the Poisson regression, we have the Poisson distribution. I think all of you are familiar with the Poisson distribution. Okay, so basically you can see here the Poisson distribution. We have a probability of y equals to k. Okay, so we are calculating the probability of the specific count data. Okay, and but the problem is that okay, we have a very special feature that the mean and the variance of the Poisson distribution are equal to each other. Okay, so for example, like lambda, for example, lambda is the mean of the Poisson distribution. Also, lambda is also the variance of the Poisson. Okay, so that's the very fundamental feature of this distribution. And then we can, if we like, maybe we'd like to calculate the expected value of y. Okay. And then maybe we like to transform the y, expected value y to be a linear regression. So you can see we can just do a little bit transformation of the function, and then you can see here we have a log lambda function of x1 through xp to be beta 0, beta 1, etc. Okay, so we call this the log rate. Okay, and you can see we also have log R's in logistic regression, but now we have log rate here. Okay, so in the following, you can see this is the regression we have. Lambda equals to exponential of beta 0, beta 1x to beta p xp. Okay, so this is the standard formula of the Poisson regression. Okay, and if you are interested in the derivation of this equation, you can go back to watch the videos. Okay. Okay, you can go back to watch the videos. Okay, watch the videos, and the professor on the video will show you the derivation there. Okay, so I'm not gonna do that again here because just like I mentioned, I'm not so interested in the Poisson regression. Okay, because of its lack of application in the finance cases. But if you are really interested in this, you can find some recent literatures to see if there's any studies on these topics. Okay. Okay, so this is Poisson regression, and then we have some applications here. Okay, before we start this example, let's take a break first. Okay, be back later.